Okay, we're going to look at one more method for solving a system using matrices, which is called Cramers Rule. So right now you know Gaussian elimination, Gauss-Jordan elimination, and now we're going to look at something called Cramers Rule. So this is a really nice kind of quick way if you like using determinants. So we're going to look at where this idea came from, and the process goes like this. Okay, let's see. If this is my original system, and I want to try and use elimination to solve for, I got to be a little careful here, there's a little typo. We're going to change that y to x, and on the other side, we're going to change that to a y. Because if you look down below, we were solving for x, and then we were solving for y. So let's see. To use elimination to solve for x, we want to make the y's cancel out. And so if we're going to eliminate the y's, we're going to multiply by d and by b, kind of like the opposite things. So that will leave a dx plus dby. That's our first equation, rewritten. Now also multiply the right side by the d as well, so that gets us de on the right side. The second equation, multiplying that by negative b, makes negative bcx minus b dy equals negative bf. So that makes my y's cancel because I have a positive db and a negative db. So what I have left here, it has separate boxes for my terms. So I'm going to have a dx minus bcx. And same thing, these guys are going to come down and they're writing de. It says minus, so I'm just going to write bf in there. And so then they took these two terms, and we can't combine them exactly, but they both have x, so we can pull that x out. We'll be left with AD minus BC. That should sound a little familiar. And then on the right side, we just have the DE minus BF. Now, if you want to solve for this little x, you would divide by AD minus BC. So we divide both sides by AD minus BC. That leaves us with DE minus BF, and then that's all over AD minus BC. So we found a formula for x that just depends on the AC, BD, EF letters. So let's look and see what's going on with the right column here. So similarly, we're going to solve for y, so we have to eliminate x. So if I have an AX and a CX, I can multiply by kind of their opposite letters to make them kind of cancel out. So the first equation will become, let's see, negative ACX minus CBY, and the right will get negative CE because all sides need to multiply by negative C. The second equation becomes ACX plus ADY equals AF. And you can see exactly what we wanted. The negative ACX and positive ACX cancel out. So then I have this negative CBY I need to write down here. But notice they put a little minus here, so I'm going to write that actually as the second term. That will be CBY. And then the ADY will sit in the front. On the right side, kind of similarly, the negative guy came first, so he's going to actually have to sit last the way this is written, and then that will be AF. So if I combine these two guys, well, not really combine, but take a y out, that will be AD minus CB, or BC if we write it that way, and then we have the AF minus CE. So if we want to solve for y, we divide by AD minus BC, divide by AD minus BC. So y is going to be equal to AF minus CE over AD minus BC. Okay, so right now you're like, okay, fine, there's all these letters going on. Well, let's see how they're related to something that we were already looking at, and that is determinants. See, the numerators and the denominators look a lot like things that we were looking at when we found determinants of 2 by 2 matrices. So let's see. If we want to find something called, they're going to call it big D of this matrix, you're going to multiply, remember, AD minus BC. Look at where those inputs are coming from. If we go up to the beginning up here, those are the coefficients. Erase this mess here. Those are the coefficients of my x and y, a, b, c, d. Now, I'm going to write that down. So they're the coefficients of the x and the y. Now, dx, they see a little tiny x down there. Look what they did. It replaced that first column with EF. Well, what's EF? Let's go back. EF was our constants, the answers in each of those equations. So if we replace that column with those constants, let's look at what that determinant is. We're going to have ED minus BF. Look familiar? Well, it's right up here. And then if we look at dy, we have the same thing. Replace the second column with the constants. So let's see what that determinant will be. A times F minus CE, which you can see right here. So looking at all these results, what you can see is that we can write x, which was DE minus BF over AD minus BC. It looks kind of confusing, but a little better is to say, oh, well, DE minus BF, that's that determinant where you replace the x column. AD minus BC is the determinant of just our coefficients. And similarly, y was the AF minus CE over AD minus BC. But AF minus CE was that dy, the determinant where you place the y column with the constants. And AD minus BC is d. And so we can use that to find our x and our y. So if we were to go all the way back to page 89 of our handbook and we look at our introduction to systems, we had a system of equations with two variables that said x plus y equals 190, and we had 10x plus 6y equals 1740. So if you remember that, that was our general admission and senior tickets. So we have solved that already. We did that before. And so what I'd like to do is see how we could do this using our determinants. So if we want to find matrix D, which is the denominator for our x and our y, we need to look at the coefficients. So we have 1, 1, 10, and 6. So 1, 1, 10, and 6. We want the determinant of that. Well, that's going to be equal to 1 times 6 minus 1 times 10. So we're going to get a negative 4. Now we also want to find dx and dy. Dx, we're going to replace that first column with the 190, 1740, our constants. And we need to find that determinant. So that's going to be 190 times 6 minus 1 times 1740. Well, 190 times 6 is equal to 1140 minus 1740. We're going to get 600, negative 600. So that's our dx. Let's see, our dy, we're going to replace the y column. So this little x or this little y is telling me which column to replace. So we're going to keep the 1 and the 10, and we're going to replace the 1 and the 6 with the 190, 1740. And go through this process again, finding the determinant. So we have 1 times 1740 minus 190 times 10. This will be 1740 minus 1900, which 1740 minus 1900 will be negative 160. So what Cramer's rule says, and this is actually a really nice way to solve a system, especially if there's one that has fractions involved. But all you have to do is these little multiplications and subtractions. And so Cramer's rule says that the x is found by taking the dx over d, which will be equal to negative 600 divided by negative 4, which here will be 150. Y is found by taking dy over d, which dy would be negative 160, and dividing by d, which is negative 4. So 160 divided by negative 4, will be a positive 40, which if you look back, those are the exact same answers that we got. But again, this is just another method. So whether you use substitution, elimination, Gauss-Jordan elimination, or Gaussian elimination, or Cramer's rule, all of these different methods will get you the same solution. And this can even apply now to a 3x3 system. So if you had a 3x3 or even higher, if you want to find the x coordinate, you would have to find still dx over d, the y coordinate dy over d, the z coordinate dz over d. But now you're looking at determinants that are for a 3x3 matrix, which would require a little bit more work, because you're going to have to be either using the minors to find the determinant or using the other diagonals. So you get a chance to try that in some of your homework.